Tag. My naam is Herbert ten Haven. I will continue in English, if you don't mind. We have a slideshow share, and you should see my screen. We are a company started at university, and so we are a spin-off by Professor Martijn Visser, robotics professor. And the first years we started as an integrator. And then at some point, the team won the Amazon Picking Challenge, both stowing and picking. And then we pivoted and only doing computer vision. So we are a computer vision company. And we are focused on logistics. So let me show you the next video, which will will explain which business we are in. And so it will, there's a video explaining why we are in logistics. This is what is happening everywhere in the world, 7 times 24 hours. Every single parcel is being picked by humans. And in this case, they have to put it on a conveyor, on a sorter, an induct, and then the machine scans it, and then it's being brought towards various locations. So each parcel is different. And on average, let's say, just take DHL, every parcel is being picked by humans at least 8 times, up to 16 times. So you can imagine 240 million parcels a year. How much handling is there by humans? So this is exactly the reasons why we're in this business. Like Miriam just told us, it relies on humans. Why? Because it not only varies in shape, size, color, but also in how they're stacked, and also the material can differ, which means a different handling of the parcels. And the reason what we did is we created a neural network, a product that is able to generalize. Like we as human beings, we can see that this is a box, or we can see that this is a flyer, and so we can grasp it. And so that's the key thing we bring to the market. It's a product that enables a robot to pick things it has never ever seen before in difficult situations. So how we do this? So we trained a neural network based on a few million of images, and we made it hardware independent. That means it can work with any robot, any gripper. It's just smart knowing what kind of gripper do you have available, and based on that, the robot will be guided to that part of the parcel to be picked. So when we use a camera, like we always use the Ensenso, to be honest, since already 5 years, we create a point cloud. And we also use the uEye, the RGB camera, which will give us an overall picture, 2D of the area where we want to pick. And based on our neural network, we do a few things. First is segmentation. So we need to know where one parcel ends and the next one starts. If we fail there, we fail everywhere, because then the robot tries to pick it up in the middle, and it either has 0, 1, or 2 parcels, and then one parcel ends up at the wrong location, so nobody wants that. So segmentation is the very first key step. The second step is classification. So we find all kinds of classifiers. Actually, you need to sign an NDA to understand how many. But one of them is it the box? Is it a bag? Is it a tube, a cylinder, a flask, etc.? So based on that, we know how to handle it and where to grasp it. We can also do quality control, so we can see deformables or outliers, or the ugly ones that should not go on a conveyor. Let's say if it's a football, you're not going to place it on a conveyor, because then it will fall off. So those are things that we help our clients with. Then we look at the point cloud coming from the Ensenso, and we look for a surface big enough and flat enough to attach a suction cup. You see the red area above, which represents a surface flat enough and where the robot can apply suction. So the gripper can get into that area. And so we find that area. And if you represent that back into 6 degrees of freedom, like X, Y, and Z and the rotations. Then you see that in the bottom box with the groceries, you see the angles, the X and the Y, green and red, and the Z axis in dark blue. And that represents the grasp pose we propose to the robot to grasp. That's in essence what we do. Very simple. Later on I'll tell you more, because we also do stacking, which means playing 3D Tetris. So placing an object in an unknown environment and stacking it, so you have a high grade of packaging goods in a new environment. So when we did this, the first product we created was finding corners, the hard corners of towels. And it's really funny, because now there is a company in Germany, Suet, trying to do this 4 years later, and they just find a towel where we did already in 2017. We made a product, and it's working all over the world, even in Japan and America. This product is used for picking the very hard corners of a towel and then feeding it into a folding machine, a professional folding machine. So it works 7 times 24 hours. So you can see in the examples that it's really the algorithm, the neural network, sees the difference between a soft corner when it's just bended. So if I take this as an example, this would be a soft corner, so it's not a hard corner, and this would be the hard corner of a towel. So the neural network, we made this in 2017 when it was brought live, finds the hard corners, and then a robot picks up the corner one by one and then feeds the folding machine. And now we are 4 years later. It also detects logos, so it can place the logo on top. It deals with all kinds of towels, even small ones. It can also do all kinds of colors, so black on black, red on red, etc. And we can also find defects. So at some point you want to take a towel out because it's too much damage. So when it's positioned into the folding machine, we have a clear view of the towel. And when it doesn't get a certain grade, then we can take it out. And that's all part of the neural network. So we trained it to generalize like a human being. And we told the neural network, if it is below this grade, take it out, because then we don't want to use it anymore. This is an example of automatica. The last automatica was in 2018 in Munich, where we had an open robotic cell at the Yaskawa booth, and we asked people to place in objects in very tough situations. So they really put in this gel at this position or the other flacon, and so you'll see the robot picking up very nicely. It finds the edge, the really steep edge of that item. So this is something we already made in 2017, 2018, picking items it has never ever seen before, even if in tough conditions. So we also made this gripper with 2 extra pivots, one at the bottom and also a rotation on the top. And again, we are a software company, so we give away the design of the gripper and people can use it. So all these videos are online. So which applications are we in? Of course, item picking. And item picking includes groceries. So we do a lot for groceries. So we have, for instance, 3 of our integrators, they work for Walmart. We have Fabric is an Israeli company, Israeli-American company, having a lot of installations. So we pick all kinds of groceries. Certainly, if there is water bottles and there is like a 6-pack, it represents all challenges, because first of all, water bottle is transparent. But it can also be the wrap around it can be reflective, so you can look into light if you put a flash on it. And it is a 6-pack, so you need to know that you're not picking one bottle, but you need to pick all 6. So you need to pick it somewhere in the middle. So we're very proud of our robust systems in production, really dealing with those circumstances. Another area of item picking is apparel. So we do a lot in apparel. We're really proud on that as well. And so one of the clients we work for now, we are working on 400 installations of just one single version of our software, just a single installation of picking apparel. That's always in plastic polybags. Parcel induction, so you saw the parcels in the first video, can be a box, can be a bag, etc. All induction of a sorter. We do that for all kinds of companies. Depalletising, we recently, last week we got the order from DHL, really proud because they really went a long way to evaluate all systems available worldwide, and so they chose us. So it's really, yeah, we believe we have built the next thing in this world because our neural network is trained over the years and made it better, etc. Truck unloading, I will show you an image later on. And like we said, we work with integrators. So we don't build the robot ourselves. We make it available. We have a package which includes the neural network, but also how to install it, how to maintain it, how to update it. So it's also to review the images and to review how the robot has been done. So it's a complete interface we built for system integrators, so they can use it towards their clients. So our typical one would be Van der Lande, and they place it at their clients, or AWL, and they also place it at various clients. So it's both greenfield as well as brownfield existing installations. So warehousing, of course, parcel distributors and third-party logistic providers. Now, I don't need to tell that the market is really, really huge. And last year, it really started growing more rapidly than we had expected due to Corona. A lot of people order from home. And don't forget the returns. A lot of parcels are being returned by humans, by people. So that also increased the number of parcels. And so it's really amazing how many parcels are being returned. So again, the technology is a deep convolutional neural network. We use supervised learning. So we label the image, so annotate it and train it. We supervise it and we train it how to learn. So we have full control over how it should learn, in the sense that we can take images out, like it's not relevant, and we can add some other images which are more relevant to that situation. So we are in control of how the network is being fed, and we can change it any way we want. So we have a sort of default network to pick anything, but in almost every client we really specialize to say, okay, you're only going to pick bags, like the bags on the bottom. We pick bags of powder milk from or beans and stuff from a pallet, and so we optimize for that specific application. The package, we have integrated that with the IDS sensors, the uEye and the Ensenso. So we optimize it, and normally our neural network takes less than 300 milliseconds to do everything, from segmentation, classification, quality control, up to finding the grass poses in 6 degrees of freedom. So it's really fast. Okay. The key thing I explained was segmentation. And here you see an example on the left. What happens very often is that two envelopes appear to be one envelope, but they're actually two envelopes. And that's where a lot of our colleagues, let's say competition, are failing, because their system thinks it is one envelope. And then you have a real problem. So in our case, you see on the right, you see the bounding boxes in orange, and also with a level of certainty, how sure we are that this is a parcel. So you see on the left, we are 100% sure that this is a single envelope, and on the right, it's the 0.99. So we are very sure that these are two envelopes, and that is the basics of the quality of our software. It's so robust, trained, and over the years able to deal with this situation. Next example is depalletising. On the left, you see a pallet brought to us by a client, and they said, we found out that they were working with one of our competitors, and they saw that on the box with the tape, that those were 6 boxes. And due to the tape, so in our case, you see nicely that it is 100% sure that it's 1 box, even if there is tape around it. So this is a typical example of where people think they have a good system, but at the end, it is all about dealing with these sort of edge cases or hard cases for some neural networks where they fail. And then, you can have even a percentage of 98%. But if 1 in 50 parcels need to be picked by humans, you have to stop your machine a lot, because if you pick at a rate, let's say 1.2 seconds, then you can have the human next door because or next to the robot, because you need to stop it anytime. Truck unloading or taking out a container. Example on the left, you see all the boxes taken with the uEye camera, and on the right you see the segmentation and the classification done by our neural network. And you see also the boxes on the top right that are really hard to see by humans. It is 100% sure that these are individual boxes. So this is again the basics of our neural network. Again, here some grass pose examples on the left, and you see this represented in the 6 degrees of freedom, with the blue being the z-axis. And again, you can configure it anyway, so our integrators can decide to pick this one first or etc. So it's highly configurable. We learned how to work with a lot of integrators. Everybody wants to do it a little bit differently. So we really made it easy for them to configure the way they want to use it. This is another example on black parcels, and also reflective. And this is just the default software. They just installed it and they ran it, and they were really amazed that the robot could do this. And so if you're in this industry, then so they've been in this industry for a while, and so they were like flabbergasted that this works just by installing the package, and the robot would pick these items. Okay. That's it from my side. 17 minutes. There's 3 minutes left for maybe Q&A. Otherwise, I can answer the questions later on.
Awesome. Thank you very much. There is a question. How is the Fyzir software different than other vision software available in the market?
Good question. Yeah, like I said, of course, segmentation is one of the key elements, the basics of how we work. That's one example. We have full control over the software, so we have to use supervised learning. So we control the software, how it learns, what it should learn. That's secondly, and I would say that. We are really dedicated as a team in this business. So our company is now started in 2014, so we're 7 years. So we are not the American way, like throwing a lot of money at the table and then trying to sell it and then build the better product. So we did it really like the Anglo-Saxon way, like the Germans, step by step by step. So we are a revenue-based company, so we solve problems and we get paid for solving problems. So we use the best tools available. We go for quality, and we make sure we add value, and we get paid for that. I think maybe one example in addition. In the past, we never ever used ROS, Robot Operating System. We don't trust it at all. We used to work with C++, where we moved everything 1.5 years ago, or we're moving, it's not completely done, towards Rust. There's a new development tool. Maybe some of you are aware of that with Rust, but Microsoft makes every new package in Rust. They decided to go for Rust. So it's a really very stable, very robust industrial tool to develop. And so we made all these choices. And every time we are compared with others, we've never lost. So we are quite sure we built something nice.
Sounds good. So I have a question. If a user is interested in your product, how can they start? Could you Please give us a brief overview of the next steps.
Okay. Mostly they ask us to sign an NDA first, a mutual NDA, because they're going to disclose some images. Then they disclose images. They show us like stuff to be picked, and then we can give them verbal feedback, but we can also run it in our network. So if they send us images, preferably with a good camera, then we can already run it in our network and give them back the feedback of our already just default network. So they can see the proof how well our software is able to find all the parcels or items or the where to grasp it based on just the images they sent us. We don't ask any money for it. We just want to give back to that. So based on that, it's an end user. So we can advise on we have more than 20 integrators globally that can work with us, or they are an integrator themselves, and we just help them install the package, and off they go in, let's say in a month. It should be a working system, the basics working system.